Hey guys, today we're going to be building the F-20 Tigershark. It's a 50mm EDF, and in my previous designs from Control Plane here, I've been making everything with PDF build guides that you can look at on Google Docs, and I want to stray away from that to make it a little more comprehensive and straightforward so that you can do less reading and more building. So we have all the parts laid out here. You can't see all of them, but you'll be able to as we build it. And really, building this is very straightforward. You just take sections of your filament, like right here, and you're going to use clippers to clip off segments by fitting them in the holes and getting the right lengths, and those are your alignment pegs. That's how everything here is going to fit together. You should also note before you print this is some of these parts are going to require support, specifically I believe this fuselage P3 will, and then also specifically really P4 right here. You'll see it in the parts list. It's going to be labeled as P4. It's going to be printed in this orientation top down, and this little NACA inlet here that we have for a cheater hole is going to need some support so that this bridge builds properly. I haven't tried it without it, so I assume it's just going to need it. Same with P5. So I recommend if you're using Bamboo Studios or Cura, you should be able to on Cura, but I know for a fact on Bamboo, put manual supports. So if you do manual supports, you can just put the parts that are obviously going to be problematic, like this right here needs to be supported. This, like we talked about, and these two servo holes, and this overhang here. Everything else in the design really doesn't require much tweaking for your printability. It's pretty easy to do. But besides that, printing it is straightforward. We also have a whole free set of print profiles for different printers that are available on our Colts as well. So you can get them off of there if you want to just have a pretty good plug and play experience. First thing we'll start with here is just getting the fuselage together. So as you can see, I pre-cut these alignment pegs just to save a little bit of time on the video. And our goal right now is to turn this pile of parts into a plane. So I'm just going to put some glue along here, just super glue to make it quicker. You could use whatever adheres your plastic. This is all lightweight ASA. Lightweight ASA is probably the best to use because you could use our print profiles that are available for free. And it is lighter and very heat resistant. So we just stuck together our first part here. Let that sit. And within a few seconds, we don't even need any kicker, and it's good. And since we're here at the front, I'm going to put this on. This has fixed landing gear that's optional. And this part right here is going to basically act as a nose landing gear support. So whenever you hit the nose gear on like any bumps on the runway or any grass, it won't rip apart this delicate foam material. So we're just going to put a little glue like this. And we'll align our hole on this. And that's just PETG. Could be anything. Could be PLA, PETG, PCTG. Anything solid enough. Or just plain ASA. Or even like 100% infill lightweight material will work as well, because that's typically pretty sturdy. So that's in there. That should set and be pretty secure. That looks good. We'll come over here, move on to our next fuselage. One thing you'll note that I've already done is I've put my magnets in here. This magnet tray, just so you can know, and the battery's dead in this caliper, but you can still read off of it, is about, should be 21 millimeters. So anything really 20 millimeters and below length, and about 11 to 10 millimeters in height for your cross-sectional dimensions of a magnet would work. It's about 2 millimeters deep as well. These are 2 millimeter magnets. I have a little bit of play so they can go in further and they won't stick out. So yeah, anything that's like a 20 by 10 and 2 millimeters deep on a magnet will fit in there. So just for extra redundancy, I have those glued in, and then I have these glued in too. You want to scuff the sides that you glue so that they stick better. And then that will be our canopy hatch. So we'll go ahead and get that canopy hatch glued right here. And there it is. Come back to our fuselage. So now we're getting this together. Just let that get nice and cured. And there's 3 parts of your fuselage, only 2 left to go. As you can see, our canopy hatch should just fit right in there like a glove, as it does. Nice and centered, not going to pop off. We got that. And this little seam here between the 2 parts will be the end of your window, so when you color this in with the Sharpie or mask it off to paint it, that'll make it a lot easier. You could even paint these 2 parts separate, so you don't have to worry about masking this part if you wanted to paint the canopy, but you could do it either way. And this is going to fit, just testing it. Okay, cool. Now we can get our glue on. There's our the last 2 fused parts put together right there. So you see we have one of our servos in, and unfortunately with this design being a little tight here, I wanted to have a motor hatch, as you can see, which we'll put together in a second. And to fit your Elevon wires through the motor hatch, you're going to want to have the motor installed first. But fortunately, you can unscrew it with these, and this can be fished through with like a wire. If you ever had to replace one of your servos here, or take out the motor, you could make that work, and it would just take a little bit of time, but it's all workable. That's the way I designed it, because we didn't really have any room to squeeze this wire around here. It would just be very awkward, because it's a tight fit. So right here we have our motor hatch. And that's just going to go together just like that. Well, that's your motor hatch. That's where the fan will go. The fan is going to be a 50 millimeter, just generic 4-to-5 cell fan, so this probably won't really fly well on a 3S. This one takes 4S, that's what I'm going to use. And the most common one, the X-Fly, is going to fit. We checked the dimensions on that, but as you can see, it just fits right in here. These connector tabs, you're just going to clip off. I already did it. You'll just take your clippers and clip off these mounting screws because you're not going to need them. And the fan will just fit right in here just like that, like a glove. And then it'll obviously have these that are going to connect down in there, which we'll get to in a minute, to our ESC. So now we have the tail. Since we're back here, let's get our big old vertical stabilizer on. It's just going to go on with 2 alignment pegs, just like that. So I'll glue that right now. And I did a lot of sanding of my parts and cleaning off excess stringing with my X-Acto blades. So like all the parts you're seeing right now are pretty clean compared to what they came out with. Because this ASA material is very stringy, this lightweight stuff. So it's a little bit of a compromise with printing with it. It's basically comparable to lightweight PLA. It's like what you'd expect with that too. And everybody knows that stuff, but this is better in my opinion. So here's the tail. Now, we'll come back over here and look at our wing. So you have a couple ways you can install your wing. Basically, you're going to need a 500 millimeter 4x1 millimeter rectangular spar. You can get them on AliExpress. We'll have a link. You'll just need one of them. I think they come in packs of 5. This I have in 2 pieces because I salvaged these spars out of another plane that we crashed, and I don't have extras. But they're still going to work because the main reason why we have these spars is to support the flex of this wing. This is going to be a kind of a fast, heavy jet, and we do not want this wing to flex. So you can see like this being 2 pieces doesn't really matter, but we've designed it so that you slide one piece through the fuselage and stick your wings on over it, and it's super easy to put together. So we'll go ahead and get these on here. You can either assemble the fuselage first with your wires and then put the wings on, or put the wings on and then just ignore this little peg here and not use that when you align the fuselage. So I'm going to do it the second way that I just described. I'm going to put these in first with just the 1 alignment peg because that's going to work. So you also aren't really going to need any glue on these spars. They're pretty rigid. These rectangular ones, all the load is going to be vertical. So like I cannot bend it like this way. So obviously it'll bend like this, but we have them oriented so that the positive and negative G's that you put on this plane will be very much supported here, so it's not going to be a problem. Go ahead and put a little glue here, just like everything else. And this also has no wing control, so it's just using those Elevons. You don't need to worry about any servos or any wires going to these wings, which is something we chose to do to make this as simple and easy and cheap as possible to build. And it's still going to be a load of fun to fly. So just like that, that's on there. I used a generous amount of glue like we were talking about. We didn't really need any glue on the spar, and that's already incredibly rigid. Probably more rigid than a foamy would be, like that you'd buy at a store. So that's going to be all we need there. Come over to this side. Rinse and repeat the same thing. Now, we've got 2 options when it comes to the wings. I wanted to make it scale and have the AIM-9 missiles that this has in all the pictures on the prototypes. They launched AIM-9s off of these. So this is kind of the main loadout that they were going to use. I don't know if you know anything about this jet, but it was just a prototype, never got into production. They made a couple, and you see a lot of pictures with these on. So the way you'll put those on, and with this option, the other option in the files is to just have a clean wing without the pylon. But if you want the pylon, you're just going to clip 2 pieces of your filament here. This is going to fit right over that, just like so, which we'll glue on now. And your AIM-9 will nicely fit onto that pylon with the pegs as they stick out there. So just like so. And if you want to fly it bare without the missiles, of course you can, but if you want those, which you probably do, you're just going to stick them on and glue them on there. And they'll be secured. I'll wait to do that because we're going to paint this in gray after we fly it, and the missiles are going to stay white, so I will lightly tack these on or tape them on for the maiden flight. And then after that, we'll come back and glue them when we paint it. But that's how they go on. Pretty straightforward. These are going to be assembled in 2 pieces, and so you're going to want to take this, and it's going to be mirrored. Anything that you see on this, by the way, and it should be clear in like the instructions on Colts, you're going to mirror these parts. You're going to have one file for the left wing, and you mirror it over to the right. It's the same with the missiles. Those are also mirrored. And you're going to take a clipped piece of filament. It's going to fit in here. And this is a bit long for what we need. These are kind of shorter than the others, so I'm going to clip off quite a bit of it. And then this little tip of your missile is going to fit on here, and it should be lined up perfectly. If you look top down, like when you glue it, this is going to be in line with the front canards on there. So we'll just glue that real quick. Let's get that right. There it is, roughly. Close enough, I'd say. Oh, let's see here. Yeah, I like that. Alright, that looks like a missile to me. There's our other one. And yeah, you just rinse and repeat for the other wing. So now that we have that done, that's most of the build with the exception of feeding your wires through and then putting the fuse together like this. So since we're going to put the fuse together like this, we can ditch that. We'll set this aside here. Get everything a little more organized. And the next step is going to be specific to people that want to make this a landing gear equipped plane that you could take off from a runway somewhere. So a lot of places now that you have a field you can go to, and it's a little easier than hand launching, but if you want to hand launch, this thing should have more than enough thrust. It's probably going to be over 1-to-1 when we weigh it, or near it, so it should be great. But for those that want the landing gear, it's all pretty straightforward to install. You're just going to have a couple extra tools. You're going to need a metal hammer that you're going to use to do something on this, which we'll get to in a second. This is your nose gear assembly, steering. And you're going to need pliers, some pretty beefy pliers, because this right here is thick wire. If I double check the diameter on it, it's spring steel. It's 2mm spring steel. You can use softer steel that will be easier to form, but the partial problem with that is that it will be a little easier to deform on hard landings. So I just prefer to just bend up the really hard spring steel. That way this thing will last a lot longer. And there's internal support in here for the landing gear mounts. It's like multi-layered supports within the wing that are connected to some of the printable spars. And it's going to be very rigid for landings. So it should be pretty durable combined with this strong steel. But you can use other stuff too. And basically, the way you're going to bend these is you will take your wire, take your pliers, and there's going to be a little nub that sticks out in there, as you can see on the very end here. Then you're going to bend that just long enough so that it doesn't poke through the wing. You're going to bend your second section and just use this little canal here as a guide. It makes it pretty straightforward if you just line it up, maybe mark it with the Sharpie, and then bend it. Use that as a guide, come over here. And then for this long section, the lengths for this and the lengths for this part of the nose gear, these two long sections will be posted on the Colts post, so you'll just know exactly what to bend those to. This is going to require a third servo. 3 servos total if you have fixed gear in this, but it's still pretty simple. So I'll take this servo off my receiver for a sec here. And this is going to basically go in here, and I'll show you how I'll do this. So I'm going to take my hex bit and show you the assembly on here and how this works. So it's pretty simple design, pretty reliable. All we have is a couple parts here that are pretty important, but they're very robust. These are printed out of PETG right here. I recommend PETG. You could also do PCTG, maybe ASA, like a solid ASA part might work, but I've always used really solid plastic. Nice because it's also heat resistant compared to PLA. If you have this out in the sun, you don't have to worry about this melting. And you've got a landing gear mount piece, and then a landing gear steering arm. And that steering arm is going to have a set screw. And this set screw, if I'm not mistaken, is a M2 or an M3 screw. I'll put it in the description. But you can use actual set screws of that size or just a good old screw that you get in a pack of those screws from China. And this one has a hex bit, so the way you'd install this, and it can get a little tricky, but we'll do it. We'll show you. We have this support put on here now. Very important. We're going to put this steering arm through here, so just our main landing gear arm is going to fit through here. Squeeze it in. And now we can come back to the nose here. And we're going to feed this, and this is where things get a little tricky, a little awkward sometimes. we're gonna feed this into here. And see how that lines up essentially here, like that. So then you're gonna fit your arm on when you do all that. And then the arm is gonna be positioned off to one side. And the way you make sure that it's going to set the screw off to that one side is where you need a metal hammer. That metal hammer, I recommend just using it on some hard concrete, or like if you have an anvil or a good piece of hardened steel, you'll do that. But that metal hammer you're going to smash the end of this hardened steel wire, which is possible and just takes a little bit of time and effort. Just smash that down with your hammer, and then you want to have that angled off so that this arm is cocked to the side. That way when you tighten this set screw, it looks something like this, and you can kind of see if you look top down here, and I'll actually do it to show you in a sec here. Just finger tighten it for now. You'll see that it's something offset like that, so that your arm, your steering arm, is like that, this way, and then your landing gear steering arm is here. So axle, steering arm, that's what I was trying to say. That way you have a little bit of play to move it before this hits the nose wall, because there's a wall in there that you want it to bump up on. So they're not parallel to each other, the way that flat spot is, so it'll be angled. So that's how you do that. You then install it, and then you loosely just put a servo in there with a little arm made out of some thinner wire. You don't have to use super thick wire like this, just like good old control wire, maybe 1mm wire, something like that. And you just glue your servo in somewhere in here, out of the way of your battery, maybe even upside down like this. And you can use that to have nose steering. And this is something we have on all of our other designs, and it's really easy to do if you have the right tools. And it gives you pretty good ground handling, really no trouble there. You just, one note, you don't want to over-ream this screw because this is plastic, so if you tighten this too much, it'll slip. I even recommend getting it just snug, making sure this isn't budging, and throwing a little bit of glue on that screw to prevent it from backing out. Okay, just did a couple things off screen there to make it a little easier, but what I just did is I got that piece installed on the nose landing gear like we were talking about, and I don't have it glued in yet. It's going to be easier to get that servo all linked up while this is loose and to get the wire in. So I did that, and then I glued on another part of the wing here, and I got started on my landing gear down here. So I glued this one in. We'll do the next one together. So I've got that wire tweaked. I tweak it the best I can before I glue it into the plane, just so I don't have to ream on it too much, but we want to get it pretty straight. And this one is looking good. I'm just going to test fit it in this hole here. And I bent this one a little off from what I really wanted, so I'm going to adjust that. Alright, that's better. Now what I'm going to do is I'm going to hold that in place. Next step is going to be putting the fuselage together with our motor and ESC. And we want to extend some wires here. So you're going to need to have an extension. You can buy these and have them soldered together done for you, or you can just make them yourself. You're going to need some extension wires probably on your ESC. We couldn't make the hole much bigger on the design here just because of the way it would fit through the rest of the fuselage. It wouldn't work. So you'll need to do that. And then after you use a little bit of minor soldering skills there, you'll do the same thing on both of your Elevon 8-gram servos. So we will get a servo out here and we'll show you how to do it on one. I already have one done. Now, this next part is something that I prefer. You can take these little heat shrink tubes with a barbecue lighter like this, and it makes your soldering job way easier to do if you want to do it that way, or you could solder it by hand and be a pro, but I like to do things a little quicker here, so this is what I do personally. Let that sit for a sec, get the next one ready. That one's done. And we have one more. Okay, so now that we have these all soldered, The other modification you'll do to your 8-gram servos is you will clip off these tabs just like that, because that's going to impede them from fitting into our little slot back there. So we'll get that done. And now we're going to kind of get this together here. I'm going to do this the smart way. I'm going to take these off. I did this backwards. So when you're using this extension here, it's going to make your life easier if you can connect these to the motor and slide the motor through. And this is why we keep the fuselage in half before we put everything in. As you can see, it's probably pretty obvious now why you want to do that. But we will take these, put them on here, like so. Take this, put this on here like so. And same here. It's going to go right through here. So now we got these through here. This will be a little bit easier. So this is what's going to really join our fuselage together. Now we've got our servo tester. The reason for this, like I said, is we just want to make sure that we have the proper motor direction before we put everything together. It's going to make our life a lot easier. Looks like yeah, that is the correct direction. So that's that. You can shut this off. Next we want to check the direction and centering of these. So we just want to get these bad boys centered, and you'll see why. So we're going to put these both onto this, and we want to make sure that they're working. So we'll put this on out. Take our other 8-gram over here. And you're going to check the centering on these, which is very important because when you install your elevons, you do not want to install them and glue them when they're off-center. That would be kind of a bummer. So we're going to get that right so that they're nice and even. We're just going to set them neutral with this. And now we can plug this into the opposite side to use it as a battery source. Our ESC can come back in handy here again. And that is the correct direction. So now these both are working. You can feel them both moving. They look good. Now I'm going to hit neutral on them, and that's neutral. They're set to neutral, so we can unplug this now. And now we are about to glue the fuselage together. So we want to make sure we do this right because we've got multiple surfaces. Now I got a little bit of warping on my print there just because I wasn't using the right bed type on the one printer that I used. But we're going to get this all together. You're just going to put a little bit of glue along here. So there's that. I'll squish this on here because that warping occurred, so I want to just press these together. And this super glue is going to do a super good job of adhering everything. So now we got that kind of set. Flip it over. And we didn't really get this bottom seam here, so I'm going to put a little bit on that and just rub it in with my finger. I might as well just go along here and add a little bit more, just so these wings stay on. And rub it in. Get your fingers a little dirty or put on a glove if you care about this, or use a little rag. Now we've got this put together. We've got our motor in place here. And because this motor's in place and we have the right direction, which we checked, now we can install our motor hatch. So we'll go ahead and take this. It's going to be a little bit of a trick to fit. And I probably should have trimmed more excess material off this motor hatch before I installed it, but this will still do. It doesn't have to be perfect. It's going to be installed there, just like this. I'm going to double check here. Let's see, there's got a little excess material here I'm going to scrape off. Use a little sand. You can take a sanding block and get this to fit better. And this should fit a lot better. And this fan, by the way, is a pretty generic one from, I think it was Hobby King. It's off of their 50mm F-18. It's going to be the same size as your X-Fly fans, which are great fans. Now, I'm going to get my screws. These are M2 size, so you could use the M2 Phillips screws that you commonly see, or just M2 like threaded hex bit screws as well. So we're going to put these in here. Just hold down the side of the motor hatch that you're screwing while you do this. Alright, there we go. Nice and flush. And you could just skip that whole step and glue it if you feel like it. Now, this is what we're left with here. Tuck some of this away for now. Not much left to do on the jet. See, the wings are going to be very rigid. And if you do put glue along the spars, which is not necessary, they'll be even more rigid. But you can get away with not putting glue on the spars. But that's good. So now we're going to direct our attention over to the tail. And we got to get these servos in here that we centered with our servo controller to fit in. So we've got our elevons now that we're going to work on. Come over here. If you have trouble getting this in, you could use a very thin feeder wire. And if you want to make this whole step easier, you could have also put those wires through the fuselage while it was still in two pieces. If you take this feeder wire through here, and you will see that it should be popping right out on the back here. Which it is. We've got the wire sticking right there. So we're going to pull our servo through. Our servo lead wire. Look at that. There she is. We'll do the same for this other side. And these do not have a Y harness because they're elevons, so you don't need a Y harness to worry about. I'm just repeating this for the other side. And we've got this here. And there it is. So we have those fed through. That's great. That's one of the harder things to do on this build. That's all done. Remove this. We don't need that anymore. And now we're going to test fit our elevon servos. So this prototype has a little issue with how they fit, and I had to cut some material out. But on the version that you will be building, the released one, it's going to be much easier to get these in. You'll see that I'm having a little bit of trouble here, and that's just because this is the first version. So we're going to increase those tolerances and make it a little easier, but it'll still go in even with this. And just get that squished in there. It'll go any day now. And those are going to go in. And they're just going to sit right in those pockets. And now on your stabulator, it's also a mirrored part just like the wings when you print them. I got a little bit of warpage on mine, you can see. Normally it would be flat if you had the right print build plate to build this with, if you're using the ASA, because it's prone to warping, as we've talked about. All this is going to do now is we're going to take our arm, this piece, you're going to clip these ends off. It's going to fit right in here. And these are the DS Power servos, so if you have something else that's 8-gram size, it might be a little different. This is specifically designed for these because they're really good servos and they're lightweight. You really don't need 9 grams on this. And it's just going to go on like that. And this is going to fit in a little more flush on your version. On mine, I've got a little bit of play, but basically it's just centered on there. And you'll have a little less of a gap. It's going to be nice and tight. What we do before that, and what we're going to do right now actually to show you, is we'll do it for the right one. I'm going to take this servo horn pack, and we'll do exactly what I just mentioned. So we're going to take this out, clip that off, and we're gonna take our servo, get this screw that's in this bag. It's very important to have this because we want our stabilators to be secured, and screwing them on is gonna make them never come off. So we'll get a screw bit for our little tool here. This one's a little large, I'll be right back. Yeah, this will work. And you're gonna get this to screw on. Oh no, I dropped it. We'll get that back. You're gonna fit this on here as neutral as possible. The idea with getting these centered is to have both of them at the same position so that when it is trimmed to neutral, when you actually hook up your radio, it will fit neutral. Like, you're not gonna have one stuck up and one neutral, because you won't be able to really fix that very easily. So we're gonna screw this, well, yeah, we're gonna screw this on. We're just trying to not let this servo twist at all, so we're holding it pretty tight. If it does move a little bit, not a big deal. I just want it pretty closely right there. It's moving just a tiny bit, but I'm just getting it on. I know that's pretty much neutral. And we'll test fit this, and it's just gonna fit right on. So that's pretty close to neutral. And if it wasn't, you would just note that it's a little off, but that's, yeah, that's right on there. So it just fits like that. And I'm gonna take this servo out. And we know roughly where that position is now. We know that what we had it at was neutral, so we could put it back there in a sec. And we're gonna pull this back out. We're gonna put this over to the side. And which way do we twist it? We twisted it this way. Make sure you don't get it backwards. I'm gonna put this on here. And then we're gonna do something a little tricky here. And this might take you a little bit of time to get, but we're gonna put these screws through two of the servo holes, the horn holes, so that if we ever wanted to unscrew this and remove it, we could, if we were able to remove our servo. But you could also entirely just skip this step and just glue the horn right on. And the key is to get it near neutral. If it's not perfectly neutral, that's alright. That's what trim is for. It should get it close enough when we put this all back together. So that's pretty tight on there. And if we still have some play, which we do, and that doesn't secure it, which, you know what, in this case looks like it's not, I'm going to just glue this on. And just make sure you don't get any of that glue into your servo gear. That'd be a bad day. So just a little bit of kick on that. Make sure it doesn't spread anywhere else where you don't want it. And that should be pretty damn rigid. And oh yeah, no, that's nice. And now that we put a ton of glue on that, without getting it in the gears, super tight, very little play. Come back here, pull our wire through. And again, yours will be a lot better fitting than this. This is the prototype, the first version. And that's going to go in there and get glued. And then when we do glue it, it's going to be a little more flush. It's just kind of popping out. But that's pretty tight. That'll work. Good with that. And yeah, you just do that for the other side. So I'll run through that real quick. And I already have the screws in, so I'm just going to unscrew this one. And then you'd obviously, and I'm going to do it off screen here because I'm going to get it trimmed out with my radio, going to glue this in, that servo with that. And just lightly do it in case you need to remove them. But that is pretty much our entire build. We just didn't go over how to do this, but we mentioned that you're just going to keep the servo loose. And a 3.7 gram servo is all you really need. This one's a used one, but you're just going to put it in there with your wire. And yeah, you can install your missiles and all the fun stuff. And there it is. That is your F-20. I'll have a flight video coming up here very soon.